Okay, good morning, everyone. Today, our group, which is me, Lo Yok Fong, Ng Ziying, Ong Tian Yuan, Go Anjie, and Yong Ziying, will present the concept and algorithm in adding fractions. So, what is fractions? A fraction is usually considered as part of a unit whole. For example, we can see there was a square and it is divided into 4 equal parts. And one of the parts is shaded, so it is mean 1/4. Okay, next. So now we will like to show 5 different resources, which is fraction strips, fraction circles, number lines, questionnaire rod, and fraction tower in adding fraction. So let us have a look with example 1, which is proper fraction plus proper fractions. And the example we prepare here is 2/6 plus 3/6, and y is equal to 5/6. Next. So there was a white bar here. Then this white bar actually is equal to 1. So the question is 2/6. That means we need to put 2 tiles of 1/6. And then plus 3/6. That means 3 tiles of 1/6. So now there will still have one place is empty. That means the total here will be 5/6. Okay, next will be fraction circles. The fraction circles, which means a circle, it will be divided into 6 parts. And 2/6, that means 2/6 will be 2 parts of the circle will be shaded, plus 3/6, which means 3 parts of 6 is shaded. And now add it together, combine it, and it will become 5/6. Next will be a number line. The question is 6 fractions of 6. That means the number line will be divided into 6 line, 7 line including 0, and 2/6, which means jump from 0, 2 steps from 0, and then plus 3/6. That means 3 continue with 3 steps. So the place stop at here now will be 5/6. Okay, next.
Okay, now I will present the questionnaire rods. So for the question 2/6 plus 3/6. Okay, first I will introduce what is questionnaire rods first. So we know that in questionnaire rods, each color is representing one value. For example, white color will be representing the 1, while the red color will be representing the 2. So for the first step, we will represent the both fractions with the rods first. And we know that the first fraction will be 2/3, and we will put two white rods on the top and 1 green rods at the bottom, while for the second fraction will be 3 white rods and 1 green rod. After that, we will look at the color of the denominators. So we know that both fractions are having the same colors of the denominators, which is 6. So for the same denominators, we can straight away add the fractions. So we will just combine the upper rods, which is 5 white rods, and we will get answer 5/6. Next.
Ziying, for the Cuisinart rods, go back to the Cuisinart rods.
Yes, madam.
Because you know this is already 2, right? The first part, 2/6. So 2, we have a red rod here, that is 2. We can straight away use a red rod, and the other side we can use a green rod. So 1 red, then you can show red and green together, so you get a yellow piece, yellow over the dark green. So that is 5/6. Okay?
Okay, madam.
The colors are already given already, so we can use the colors.
Okay, madam. So we will continue with the fraction tower. And we know that fraction tower is the interlocking cubes, which represent the different parts of a whole. So for the addition, 2/6 plus 3/6, we will represent the fractions with the fraction tower first. So for the 2/6, we will just take 2 cubes of 1/6 and log it together. And while for the 3/6, we will take 3 cubes of 1/6 and log it together. Since the cubes are in the same size, so we can just combine it and log it together, and we'll get 5 cubes of 1/6, and it will be 5/6. So that's all for the fraction plus fraction. So next slide, we will continue with proper fraction plus whole number. And the question will be 3/4 plus 2, while the sum is 11/4. So we will start with the fraction strips. So we know that fraction strips are strips with different parts of a whole. So for the first step, we will represent the 3/4 first with the strips, and but by folding and shading it with 3 parts. And after that, we will represent the 2, which we know that the whole number, which is 1, will occur when the numerator and the denominator are the same. So for the denominator in this question, which is 4, so when we want to get a 1, we have to make the denominator 4 equals to 4. So will be 4/4 equals to 1. And the question asked is 2, so we will need 2 sets of 4/4. So we will represent the strips, and after that, we will combine the strips and count the total parts of the strips, and we will get 11/4. So that's all for fraction strips, and now I will pass to Tianyuan.
Okay, for fraction circles, okay, the first picture will be 3/4, which is the proper fraction. And there's another 2 picture which is 2 pizza, which is whole numbers. The whole numbers for 1 is equals to 4/4. And so the total here will be 11/4. Next. For number lines, uh, 3/4 plus 2 equals to 11/4, and we can see on the number lines, which is shown 3/4 plus 8/4 equals to 11/4. For this, 3/4 plus 4/4 and another 4/4 will be equals to 11/4. Next, I will pass to Anjie.
Okay, now I will talk about the fraction tower. First of all, we must change the whole number 2 into the fraction. After that, we can find that 2 are equal to 8/4. Later on, we can add up these 2 fractions, and the result we will get is 11/4. Okay, another example is proper fraction plus mixed fraction. The example we will talk about is 2 and 1/6 plus 3/6 equal to 60/6. The first one is fraction strips. It's the same. We must change the 2 and 1/6 into improper fraction by using try and error method. We can find that the 2 and 1/6 is equal to 13/6. After that, we can add up 13/6 with the 3/6. Then we will get 60/6 as the result. For the fraction circles, for the fraction circle, we will add the we will add the 2, and we will change the 2 and 1/6 to 13/6, which means we show in the pictures, and we can add it together to get 16/6.
Okay, so for now, I will continue for the number lines. As we can see from the question, 2 and 1/6 plus 3/6 will become 16/6. We can convert into 13/6 plus 3/6, which means 2 and 1/6 represent 13/6. So the final answer will be 16/6. So from the number lines, we can see from the 0, we move on 13 steps, we will reach 13/6. After that, we will add on 3 steps. Then the final answer will be 16/6. Next, okay. For this quaternary road, we will look at it. The first will be 6. The upper will be 6 and the lower will be 6 also for two parts. After that, we will need to add on 1/6, which means 1 rods on the top and 6 rods at the below. After that, we will add 3 rods on the top and 6 rods at the below. So the answer will be 6 plus 6 plus 3 plus 1 will represent as numerators, and the denominators are the same, so it remains the same. The final answer will be 16/6. The final is fraction tower. For this question, the 1, because of 2, so 1 will represent 1, 1 will become 2. So we need to convert it become 1/6. So for here, it will become 13/6 at here. So the next slide. 13/6 will plus 3/6. Then the final will be 16/6. So for this question will be like that. So thank you for our presentation.
So you didn't show us anything about algorithms. How to add fractions using algorithm. And the other thing that you didn't show us is all your fractions were with same denominators. You didn't show us something like with different denominators. For example, 1/4 plus 1/3. How do you do that? Okay. And one comment that I want to make is that when you add, like say, for example, you say 2/1/6 plus 3/6. 2/1/6 is a mixed number. It's already in a simplified form. So we don't have to convert the 2 into fractions anymore, okay? So we already have we already have 2/1/6, right? So the 1/6 plus the 3/6 is 4/6. So our answer is 2/4/6 straight away, okay? So don't get confused that you don't have to convert mixed numbers to improper fractions all the time, unless they ask you to show how you convert mixed numbers to proper fractions. You do that way lah. If they don't ask you to show that, you can add directly, okay? Because our final answer is always in the simplified form. So other than that, okay, only thing I didn't see any algorithms there lah. Okay, let's go on with the next group first, and then I can add on lah.
Okay, we can start my group.
Hello, good evening, everyone. So this is our group members, Izati, Masturina, Afiq, Aina, which is me, and Ain Yasira. So we'll be presenting about addition in fractions. Okay, continue, Afiq. Okay, so firstly, we're going to touch proper fractions. Okay, next. Okay, so using manipulatives, which is the fraction tiles, teachers can teach concept by example, the sample question 1/3 plus 1/3, what equals to what. So some student which don't know the concept of addition in fraction yet, they will answer 2/6. But the teacher feedback will be we add the numerator, which is the upper part of the fraction, to get the parts. I'm sorry. So we are adding the fractions by adding the numerator, not the denominator. So in this case, 2/6 is not equals to 2/3. So the teacher will use fraction tiles to demonstrate how is it, why is it different? Why is the student's answers wrong? So by representing 1/3 plus 1/3 with 1/6 and 1/6 and below the 1/3, student can see that 2/6 is actually half of 1/3 and 1/3. So to get the fraction, the denominator stays the same when it is equals to. Next, Afi. So in this case, using fraction tiles, when adding proper fractions with common denominator, firstly, the teacher can represent the fraction using the fraction strip side by side, unattached yet. So 1/4. So there is this 1/4 on the left, the fraction strip, and on the right is 3/4, which consists of 3 1/4 fraction strip. So and then the teacher will arrange the fraction with smaller denominator to represent that 4 parts of 1/4 is actually equals to 2 parts of 1/2. So, and then the last step is the student learns how to simplify the fraction. 4/4. Okay. Oh, sorry. This third column is a mistake. So at the third column, the student will simplify the fraction, which is 4/4, also equals to 2/2, which also equals to a whole number, which is 1. I'm sorry for the last column mistake. Okay, next, Afiq. For proper fractions with unlike denominator, the teacher will explain to the student that every addition operation, the denominator has to be the same. So, and then the teacher will use the fraction strip side by side, 1/2 plus 1/3, and arrange the fraction that equals the same value by length of the 1/2 plus 1/3 below the fraction strip, and then lastly equals the 5 parts of 1/6, and then that is the question. That is the answer. Sorry. Okay, next. It's this also applies to fraction circles, where the amount of the parts in the circle for 2/3 is not the same as 2/6. Okay, next, Afiq. Okay, so this is a questionnaire rods. The title is wrong, I'm sorry. So for this questionnaire rods, the left side is 4/7 and the right one is 3/7. So 4/7 plus 3/7. The teacher can simplify the questionnaire rods for the white questionnaire rods to their other value, which is for 4 white questionnaire rods, which equals the value 4 is the color purple, and value 3 is the color green. And then equals to 7/7, which also a whole number, which is 1. Other manipulatives that we find is a Numicon and PAX. So this Numicon is like a template for different value. So there's if the denominator is 1, then there's only one whole, and etc. So in this example, if the denominator is 3, then the template has 3 wholes, and the numerator represent as the pack represent by the packs. The pack represent what I'm saying. The numerator is represented by the packs. So 1/3, because there's 1 pack and 3 whole on the Numicon, plus 2 packs over 3 whole of the Numicon equals to 3 packs on 3 whole of 3 Numicon whole. So that is also equals to 3/3, which is 1. Okay. Next is Izati.
Okay, thank you, Aina. Okay, now we're going to look at standard algorithm of addition in proper fraction. So basically, as what you already know, a standard algorithm is a specific method of computation which is conventionally taught for solving particular mathematical problems. Okay, so for proper fractions, I have divided it into 2 different cases, which is the first case is when the denominators are the same. And the second one is when the denominators are different. But first, we're going to look at the first case, which is how to do it when the denominators are the same or common. Okay, as what you can see on the slide, the given mathematical problem is 1/4, also known as 1/4, plus 2/4 equal to what? So first step, you gotta make sure that the denominators are the same, obviously. After that, add the top numbers, which is known as the numerator, and put them over the same denominator. So for the numerator is 1 plus 2 equal to 3, while the denominator stay the same, which is 4. So regarding to this, sometimes you might come across a student that may ask you why we need to find a common or same denominators. So basically, we need to have a common denominator given to the fact that it is equivalent to finding a common partitioning, so that we can count to find the sum if the fraction is in equal size. Okay, next. Okay, next we're going to look at how to solve the problem if the denominators are different. Okay, as what you can see on the slide, the given mathematical problem is 1/2, also known as 1/2, plus 1/4 equal to what? Okay, so the first step is to find the lowest common multiple, LCM, between the denominators of the given fractions. Okay, the easiest way to do that is by list down the multiple of 2 and 4, as what you can see on the slide. So based on the list, it is known that 4 is the LCM. Okay, second step is to multiply the numerator and denominator of each fraction by a number, so that they have the LCM as their new denominator. This process is called creating equivalent fractions. Okay, still in step 2, we need to find a number that when multiplied to the top and bottom of 1/2, we will get the LCM as the new denominator. Okay, since 2 multiplied by 2 equal to 4, we need to multiply the numerator and denominator of the 1/2 by 2. As for the second fractions, which is the 1/4, notice on how the LCM is already the number of 4, so we leave the fractions as it is. Okay, now that the denominators are the same, so we can go ahead and add the top numbers, which is 2 plus 1 equal to 3, while the denominators stay the same. So in conclusion, 1/2 plus 1/4 equal to 3/4. Okay, next. Okay, so before, we have learned on how to solve an addition fraction problem by using standard algorithm. Now we're going to look at how to solve the same problem but by using Eldon-Adif's algorithm. So as what you already know, Eldon-Adif algorithm allows students to look at mathematics as a process and provide them with an opportunity to think about applying multiple strategies for solving a problem. The previous standard algorithm can be efficient, but they do not necessarily allow the student to see why they really work. Okay, so for the first case, which is the condition of having the same denominators, we can use methods of drawing area model or by using number line. Okay, let's look at the drawing area model first. So instead of using the traditional and standard way of solving the equation, we can represent the fractions in two square shapes where both of the squares were divided into 4 equal parts. Okay, for instance, for 1/4, we shade or loretkan one part out of the 4 parts. And the same goes for the second fractions. We shade 2 parts of the square. So as the final sum, we just combine what we have shaded on both squares into 1. So it is equal to 3/4. Okay, the second method is by using number line. Start by drawing a number line that goes from 0 to 1. That number one is our whole. So as both of the fractions have the same denominator, which is 4, so we're going to split the number line into 4 equal parts or 4 intervals. So as what you can see on the slide, the red bar indicating that from 0 to the first fractions is equal to 1/4. Then starting from the end of the red bars, the orange bar started from the 1/4 travels the amount of 2/4. So the end of the orange bar is the answer, which is 3/4. Okay, next. Okay, next we're going to look at how to solve the problem if the denominators are different using Eldon-Adif's algorithm. The method is by drawing rectangular model. So the equation is 1/2 plus 1/4 equal to what? Okay, so for the first steps, we're going to represent the denominators from each fractions by drawing a rectangular and also divide the part into their respective equal part. For example, for the first fractions, we draw a rectangle that was divided into half. For the second one, we divided the rectangle into 4 equal parts. So we draw the rectangles and partition based on the denominators. Then step number 2, we're going to overlay both rectangle shape from both fractions so that we can have equal partitioning or equal size. But before we shade or color the part, still at the second step, we're going to color or place shapes on each rectangle to represent the fractions. For instance, I put the circles on half of the rectangle on the top part to represent 1/2. While on the second rectangle, I put 2 circles at the sidebar of the rectangle to represent 1/4. So on the step 3, we basically just combine the overall sum of circles in both rectangles into 1, which is 6 circles. The number 6 is going to be the numerator, while for the denominator, we count the overall part in the divided rectangle, which is 8. So the final answer is 6/8, but we can still simplify the fractions to 3/4. Okay, that's it from me. Next.
Alright, next is improper fractions. Next, using manipulative, which is pattern blocks. Pattern blocks is an online mathematical manipulative that helps students develop spatial reasoning. Students use pattern blocks as area models to compare fractional regions and explore how the regions change in relation to the whole. Next. Okay, for the example question is 5/2 plus 3/2. 5/2 plus 3/2 is improper fraction, which is the numerator is greater than the denominator. So I use the hexagon that equivalent for 2 parts, and we shade 5 parts for 5/2. 2 means the part of the hexagons. So 5/2 plus 3/2. So I need two hexagon to shape 3 parts for 3/2. And then we sum the equation. 5 plus 3 equal to 8, and the answer is 8/2. And we simplify into 4. So 4 means the 4 hexagons that represent the 8 parts of 8/2 hexagons. Okay, next.
So we go for the next slide, which is standard algorithm for the improper fraction. Okay, as we know that improper fraction is a fraction that has a top number is larger than or equal to the bottom of the number. For the example is 7/4, 4/4, and others. Okay, there is a sample question which is 3/5 plus 1. As we know that 1 is the an improper fraction. So the first thing that we need to do is we have to convert 1 into improper fraction. So the next slide, which can be 5/5. 5/5 is an improper fraction. So just plus the numerator 3 and 5, which is equal to 8. Then we get the answer 8/5. To that is also an improper fraction too. Okay, the next slide. We use the alternative algorithm. Okay, the next slide. The sample question is 11/6 plus 7/6. As you know that for the standard and alternative algorithm, I use the same denominator, and this is the simple question. Okay, and the addition chart as the alternative algorithm for the improper fraction that I use, such as the numerator is 11 and 7, we will get 18, and denominator we stay as 6. Okay, next. Then we will get the answer 18/6 from the chart. Then as we know that 18 and 6 have to simplify, so we will get the answer 3 as the simplest answer. Okay, for the different denominator, we have to use LCM and get the new denominator and use the chart and standard algorithm as the earlier explained by Izati just now. Okay, but I use a simple question to let you know the concept of alternative algorithm and the standard algorithm. So that's all from me. We go to the next presenter, Afiq.
All right, for the mixed number fraction using manipulative, teachers use the fraction strips. Fraction strips or fraction bars or tiles help students can see that the same whole can be broken up into different equal size parts. Next. Okay, for the example question is 3 5/6 plus 4 3/6. So the fraction strips, teachers need three whole strips for 3. So the purple one is the whole one. So 1, 2, 3, and 1/6 need 5 for 5/6. So 1, 2, 3, 4, 5. So plus 4 3/6. 4 whole strips, the purple one, and also 3 for 1/6. So we need to sum the whole strips first. So the purple one is 1, 2, 3, 4, 5, 6, and 7. And the 1/6 have 1, 2, 3, 4, 5, 6, 7, 8. 8 is more for the 6. 8 is 6 is the limit. So, but we have 8. So we need to convert 6 for 1/6 into whole strips. So next. So when we convert the 6 1/6 strips, so we get the one whole strips for another one whole strip. So we count the whole strips 1, 2, 3, 4, 5, 6, 7, 8, and 1/6 have 2 strips. So 1/6 plus 1/6 means 2/6. So the answer is 8 2/6, and then we simplify the into 8 1/3.
Okay, now we will go to the standard algorithm in mixed numbers. First thing we need to know is if 4 plus 3/4 will become 4 and 3/4. Okay, this is the first thing we need to know. If we do an example, like Bulat has 4 orange, then Afiq gave 3/4 of orange to her. Then now Bulat have 4 and 3/4. So this is the example for the same denominator. Okay, so we can see here the equation is 4 1/4 plus 6 3/4. So how we can get 10 4/4 and 11? First thing, we have to add the whole number and the fraction. Okay, we can see here in the red rectangle, red box, we will have the whole number part, and in the blue box we have the fraction part. So in mixed number, we know mix. So what is mix? It is the mix of whole number and fraction. So here we have to solve one by one. So we solve the, you can see my cursor, right? Okay, we solve the whole number first. 4 plus 6 equals 10. And then the fraction 1/4 plus 3/4 equals 4/4. Then here, we know that 4/4 is equal to 1, which is whole number. So 10 plus 1 is 11. Okay. Now, you can see the different denominators of mixed numbers. Okay, you can see here 4 and 1/2 plus 6 and 3/4. This is the answer. Now we want to know the procedure. Okay, first of all, we can see here the denominators are different. So we have to make sure that the denominators are equivalent. Now, oh sorry, there is no fraction here. Okay. Now, I samakan dia punya denominators here. So when we times 2, this 1/2, when we times 2, it will become 2/4. Then we can solve the problem like I told just now. So we can get 10 and 5/4. Oh no, there is 5/4, which is improper fraction. So how we can simplify it? We have to take the last answer in the simplest form. So separate the whole number part and fraction part. Then we can settle down the fraction part first. which is improper fraction. So we have to convert it into the whole number, into the mixed number, and then we add both of the whole number and mixed number just now, and it will become 11 and 1/4, just like this. Okay, that is the standard algorithm for the mixed numbers. Okay, now we want to see the alternative algorithm. Okay, in this part, I just take for the same denominators because it is apply the same thing for the different denominators. So first of all, we have to make a table which is consists of 2 columns for whole number and fraction. Then we settle down the equation separately. So in this question, the whole number is 4 and 6. So 4 plus 6 is 10. And then for the fraction part, 1/4 plus 3/4, and it equals 4/4. So in here, in the fraction part, we can use the standard algorithm and the alternative algorithm in the proper fraction, like Izzati just present just now. So it will be the same. And then we can know that 4/4 is equal to 1. And then we have to add both whole number and fraction, and we will get the answer 11. Okay, this is apply the same for the different denominators. First of all, we have to separate the whole number and the fraction. Then if the fraction is different denominators, and then we have to make sure that the denominators are equivalent. And then we have to solve like usual. Okay. Oh, no. This is template. Okay, that's all from us. Thank you.
Okay, thank you very much to this group. You presented very well, very clear, all the algorithms covered, and very fluent explanation. Okay, so very good. Well done. So I just want to ask one question only. Okay, I just want to ask you, how would you do this? If you're given 1/4, sorry, let me present first. You're given 1/4 plus 1/3, and you want to use paper folding method. Okay, so everyone, can you take out a piece of paper, a paper strip? Okay, I want you to try with me, okay? Okay, what is the first step that we are going to do here? Step 1 will be to
Same the denominator.
We are using paper folding. So
Oh.
now we have a paper strip here, okay? Prepare a paper strip, okay? So this, so step 1 will be, what do you want to ask the child to do? Fold, yes,
the
fold
paper
into,
half,
or why half?
because after they fold it to half, they need to fold it one again to make 1/4.
Okay, so we can also tell them fold into 4 equal parts. We tell them to fold into 4 equal parts. So they will fold into half and then fold again, okay? So now we want 4 equal parts. So what we will get is, I hope you're doing this, because when you do, you can actually see it for yourself. Okay, so fold into 4 equal parts. Now what we want them to do? We want to represent 1/4. So
Shade 1/4.
yes, shade 1/4 or 1 part out of 4 parts. Or we can say shade 1 part out of 4 parts to represent 1/4. Okay, so they shade 1 part already. Okay, so now you have 1/4. What is the next step? So this is actually step 2 lah. Okay, what is step 3?
Fold into 3 equal parts.
Is it the same paper?
Yes, using the same paper.
Good. Okay, fold the same paper strip into 3 equal parts. Okay, so you do that. So every time you fold and you open it, you must draw the lines, the folding lines. You have to mark it so it's visible. So now you have the same piece of paper which you have already divided into 4 parts earlier. Now you want to fold it into 3 equal parts. So using a different color, mark the 3 parts. Okay, now you want to shade 1 part, okay, of the 3 parts to represent. But this time when you shade from the other end. Okay, so now you want to shade 1 part to represent 1/3. So you have shaded this. Okay, so you have shaded 1 part and you have shaded 1/3. So step 4 will be, you see the smallest section here, you can see this section here. Now you want to fold the whole paper strip according to this section. How we fold? You just press on these 2 lines here and then you fold like a fan, backward and forward until you have covered the whole strip. And then tell me how many parts you have.
Mm, 12.
12, yes. So you're going to fold the whole thing based on the smallest segment. Okay, so now you have 12 parts. Okay, so you have this 1, 2, 3, 4. So you will have like 1, 2, 3. So this is okay. So now how many segments are folded? I mean, how many segments are shaded? So you have 1, 2, 3, 4, 5, 6, 7. All right?
Yes.
So 7 segment is shaded. So 1/4 plus 1/3 is 7 out of 12. Okay, so this is using paper folding method to add fractions of different denominators. Of course, this is difficult to do with different types of larger fractions. Okay, so when you're explaining anything, you can use small fractions to show, because we're just showing the concept. The same method we will use for subtraction. Okay, but for subtraction, you shade from both the same end. You shade from the same end because you're going to take it away, subtract it. Okay, for addition, you shade at 2 different ends. Okay, so this is one method of doing that. Okay, just to top up with all the others that you have said. And the other thing that I want to say is about this. I want to use your same 4 1/2 plus 6 3/4. You have explained this correctly. Everything is correct. Just that when you do it, you have to, whatever you explain, you must show in the steps. So you said just now add both the whole numbers, which is true. So you have to write it down and show it. So to add the whole numbers, bring it together. 4 plus 6, and then only you want to add the half plus 3 over 4. So this is 10 plus. To add these two fractions, someone said earlier to use the LCM method, lowest common multiple. Okay, lowest common multiple is taught in secondary school only. Students in primary school don't learn lowest common multiple, okay? So the method that we teach them is to change this into equivalent fractions by cross multiplication. So this is 1 over 2. Usually we teach them if this is 4 times 4 times 4, or since in this case we know that we can make it same by 2, we can do that also, okay? It's 3 over 4, so this is 10 plus 2 over 4 plus 3 over 4 is 10 plus 5 over 4, which is 10 plus 4 over 4 plus 1 over 4. Okay, so we know that 4 over 4 is 1, so this is 10 plus 1 plus 1 over 4 is 11 over 4. Okay, it's exactly the same method that you explained just now, just that whatever you explain, you have to show it out in steps. Students must be able to see it clearly. Okay, this is one method. We also can use another method because most teachers won't teach this method, but I think most teachers will use the second method. 4 1 over 2 change to improper fractions will be 9 over 2 plus 27 over 4. And then we change this to equivalent fractions. This is 18 over 4 plus 27 over 4. 20, 30, 45 over 4. 45 over 4 is also equivalent to 44 over 4 plus 1 over 4. This is 11 plus 1 over 4 is 11, 1 over 4. So this method is usually taught in school, but actually we should teach all the methods. This method one is for conceptual understanding. Okay, method 2 is just a procedural algorithm. We tell them you times 4 by 2 and then you add with 1, and then you change the equivalent fraction and you just follow the algorithm. But method 2, it is for conceptual understanding. If you just do it based on your own understanding, you still arrive at the answer. So these are different algorithms for solving this kind of problems, which must be taught to all students. Okay, so when you explain later, anything that you explain, if they ask you to teach, use the manipulative and teach, you must always think in steps. Step 1, you write down the explanation and the drawing. Step 2, what you're doing and the drawing. Step 3, what you're doing, so that so that your explanation is very thorough and clear. Okay. Okay, that's all. So let's continue with group 2 for subtraction.
Okay, can everyone see my screen?
Yes.
Yes.
Okay, so we will continue with operation with fraction, subtraction. So we are from G2. Okay, first we will go to fraction and fraction, means subtraction between subtraction. Okay. The first is I think is the most standard algorithm for subtraction. First step to subtract fraction is to make sure the denominators are the same. Okay, there are example given, 5 over 8 minus 1 over 8. This is the same denominator, so it will be easy. We just subtract the top numbers and keep the same denominator. So the answer will be 5 minus 1 will be 4, 8 keep the same. So 4/8. Last step, if we can simplify, then we simplify. 4/8 equal to 1/2. Next, we another example, but the example is different denominator. If the denominator is different, we need to make them the same. For example, 2/3 minus 1/6. So we need to make the denominator become the same. We times 3, we times by 2. So, and 2 we times 2 also become 4/6 minus 1/6. Then the answer will be 3/6. And 3/6 also can be simplified, become 1/2. Okay, next is the alternative algorithm for Oh, sorry, I do not present. Okay. Maybe this clear. It called butterfly method. This given a question of fraction with different denominator. For example, 3/5 minus 1/6. So we need to make 3 box or bubble. We need to make 3 box or bubble and find the product of those figures. Then minus the upper product while below product become denominator. Okay. Look here. We make box cross. We make X like butterfly. Then the product we put at the above become 3 times 6 become 18 and 5 times 1 become 5. Then below part 5 times 6 become 30. The upper part 18 and 5 we need to minus. It will become 13 and we keep the denominator. So the answer will be 13 over 30. Okay, we give another example. 3/5 minus 1/2. Then 3 times 2 becomes 6 and 5 times 1 become 5. And the below part is 5 times 2 become 10. And 6 minus 5 is 1. And the denominator is 10. So the answer will be 1/10. Okay. This is also the same same method but different example. We can keep the same step. And lastly, this is the example that we can simplify. For example, the answer will be 10/56 and we can simplify into 5/28. Okay. So next we go to fraction and mixed fraction.
Alright, next is fraction and mixed fraction. So there are actually 1, 2, 3, 4 steps for subtracting mixed fraction and mixed fraction, but I combine it to 3. So mixed fraction, example 15 3/4 minus 8 5/6. So firstly we need to convert to improper fraction to common. First convert to improper fraction first. So 15 3/4 to improper fraction is 63/4. And then for 8 5/6, the improper fractions is 53/6. And then we change it to common denominator. So 63/4 is equal to 189/12. And 53/6 is equal to 106/12. So both of the mixed fraction have same or common denominator lah. And lastly, we have last but not least, we must subtract the mixed fraction fraction, the improper fraction first. 189 over 12 minus 106 over 12. So the answer for the improper fraction with common denominator is 83 over 12. And then lastly, we have to convert to mixed fraction. 83 over 12 change to mixed fraction is equal to 11 over 12. So that's all for fraction and mixed fraction. And I'll pass to fraction and whole number.
Okay, next we'll be move on to fraction and whole fraction. Okay, first of all, fraction of a whole number. As we can see in this question, 8 minus 4 over 5. As we know, 8 is a whole number, and whole number in fraction is 8 over 1. So we change the whole number into improper fraction, and become 8 over 1 minus 4 over 5. Then we must change the denominator to make it same. So as we can see, 8 over 1, this is the one denominator, to become 5 is time 5. So when the denominator times 5, so sorry. So the 8 the numerator also times by 5, so that equal to 40 over 5. So when the denominator is became the same, so we can just subtract the numerator, then like biasa is equal to 36 over 5. Then 36 over 5 is improper fraction, where improper fraction want to become a mixed fraction, it must divide, like 36 divided by 5, then we will get 7 1 over 5. Next. Okay, the second method is when 8 is large. Okay, as we can see, the question is 11 minus 4 over 3. Okay, as we can see, 4 over 3 is improper fraction, and it can become mixed fraction, is equal 1 over 3. So the whole fraction can be separate into 11 minus 1. Is 11 minus 1, 1 is the whole fraction, is equal to 10 minus 1 over 3. So when you get the 10 minus 1 over 3, then we can separate again into 9 plus 1. And as we know, one whole number can be fraction is equal 1 over 1. When 9 plus 1 over 1 minus 1 over 3, so 1 over 1, change the denominator by times 3, so we will get 9 plus 3 over 3 minus 1 over 3. Next. The 5 step is as we can see 9 plus 1 over 1. Before that is 10 minus 1 over 3. Then the next step is 9 plus 1 minus 1 over 3. 1 in the whole fraction became fraction is 1 over 1. Then make the denominator same, equal to 9 plus 3 over 3 minus 1 over 3. Then the last step is we just subtract it like usual. 9 plus 3 minus 1 over 3, and we will get the answer 9 plus 2 over 3 is equal to 9 2 over 3. Next. That's all from us. Thank you.
Okay, all the algorithms explained very clearly, very clearly, all steps shown very clearly. Only thing I didn't see any concepts. You didn't use any teaching aids to explain the concepts. You only explain the algorithms. So that's okay. We'll look at the second group. But the algorithms were explained very well. Okay, let's go on with the second group.
Okay, my group will present subtraction in fraction. We go for first algorithm for subtraction. Okay, Zulaika will present this part.
Okay, for subtract with same denominators, there is 3 steps. Step 1, make sure the bottom numbers, the denominators, are the same. Step 2, subtract the top numbers, the numerators, put the answer over the same denominators. Step 3, simplify the fraction if needed. For example, 3 over 4 minus 1 over 4. Step 1, the bottom numbers are already the same. Go straight to step 2. Step 2, subtract the top numbers and put the answer over the same denominators. 3 over 4 minus 1 over 4 equal to 3 minus 1 over 4 equal to 2 over 4. Step 3, simplify the fraction. 2 over 4 equal to 1 over 2.
So we go to the subtraction with different denominators. So for the example, 1 over 2 minus 1 over 6. Okay, next slide. Okay, for the step 1, the bottom number are different. So we have to make the denominator same. So see how the slice are different size. We need to make them the same before we can continue because we can subtract them like this. Okay. So to make the bottom number or the denominator same, we have to multiply the top and bottom of the first fraction, 1 over 2 by 3, like the picture you can see above, bottom. Okay, then you can see at the right side, now the question have changed from 1 over 2 become to 3 over 6, then minus 1 over 6. So the bottom number and the denominators are the same. So we can go to the step 2. Next slide. Okay, step 2. Subtract the top number and put the answer over the same denominator. So 3 over 6 minus 1 over 6 equal to 3 minus 1 over 6 equal to 2 over 6. And to make it clear, you can show the picture or like pictorial picture like the pizza at the bottom to make the your
people more understand. 3 over 6 minus 1 over 6 equal to 2 over 6. Then we go to step 3, which is simplify the fraction, which is from 2 over 6 equal to 1 over 3. Okay. Next slide. So this is for the subtracting mixed fraction. So for the example, what is 50, 3 over 4 minus 8, 5 over 6. So like we can see there is mixed fraction. So we have to transfer the mixed fraction to the improper fraction first, which is we have to 4 multiply 50 and plus 3 equal to 63 over 4, and 6 multiply 8 plus 5 equal to 53 over 6. Then when we get the answer, we have to make the denominator same, because we can see that the denominator is not same, which is 1 is 4, 1 is 6. So we have to make the common denominator of 12, which is 63 over 4 becomes 189 over 12, while 53 over 6 become 106 over 12. So when we have changed the denominator to be the same, we can subtract it. So 189 over 12 minus 106 over 12 equal to 83 over 12. So when we get the answer, we have to convert the answer into the mixed fractions, which is 83 over 12 equal to 611 over 12. Okay. Next.
Okay, next we will see manipulative method for subtraction in fraction. First, I want to tell about fraction bars. This fraction bars, look over this fraction street. Each street represents one whole. So one whole equals to 2 halves, and then 3 thirds, and then 4 fourths, 5 fifths, 6 sixths, and so on. So we get that 1 equals to 2 over 2, 2 over 2 equals to 3 over 3, then 3 over 3 equals to 4 over 4, so it goes like that. Then we will see how we want to do in subtraction. Okay, for example 1, the question is 5 over 6 minus with 1 over 6. So first, we draw out 5 blocks with 1 over 6 label on each block. And then we cross block according subtracted amount. So the amount that we want to subtract is 1 over 6. So we cross the block 1 over 6. And then calculate the blocks that left. So we get 1 plus 1 plus 1 plus 1, we get 4. So we get the answer, the final answer is 4 over 6. And next, for example 2. Okay, first we get here that the denominator that is unlike. So we have to change the denominator first to be same denominator. So 7 over 8, and then 1 over 4 we change to 2 over 8. So then we draw out 7 blocks with 1 over 8 label on each block. Yes. Okay, next we go to 2 over 8 that we want to subtract, and then we cross the block according to subtracted amount. Hello? You guys can hear me? Hello?
Yes, Aina, we can hear you just a little bit softer.
Okay, sorry. Okay. I repeat. Okay, for example 2, the question is 7 over 8. So we want to minus with 1 over 4. We can see that the denominator that is unlike denominator. So we change first to get the same denominator. 7 over 8, and then 1 over 4, we change to 2 over 8. So our next step is draw out 7 blocks with 1 over 8 label on each block like this. And then we cross the block according to subtracted amount. We want to subtract 1 over 4, so we cross the 2 blocks. Okay, next we calculate 1 plus 1, 1, 2, 3, 4, 5. So the final answer is 5 over 8. Next, for example 3, the question is 2 over 3, we minus with 1 over 2. So we want to change the denominators with same denominator. So we get that 4 over 6 and 3 over 6. Okay, 1 over 3 and 1 over 3 same to 2 over 3. And then we draw out 4 blocks with a label that with 1 over 6 labels. Okay, so we cross out 3 blocks because 3 over 6 is the amount that we want to subtract. Okay, so we get that the final answer is 1 over 6. Okay, that's all.
Finish ready?
Yes, Nida?
Any more from this group?
No, that's all.
Done already, yeah? Okay. So, okay, this is quite good. At least the last part, we can see some concepts and all that lah. Okay, so it's much clearer. Anybody got any question? Okay, so
No.
Okay, so we continue with the next one, multiplication.
Okay, now my group will present the multiplication of fractions. Okay, next. The concept of multiplication of fractions. There are 3 types of fractions, which are proper fractions, improper fractions, and mixed number fraction. Proper fraction is the numerator is smaller than the denominator. Improper is the numerator is larger than the denominator, while the mixed number is a combination of whole number and a fraction. Okay, the multiplication of fraction is not like the addition or subtraction of fractions. Where the denominator should be the same. Any 2 fractions with different denominators can easily be multiplied. But we need to take note that fractions should not be in the mixed form. They should either be proper fractions or improper fractions when we do the calculation. There are a few steps to multiply fractions. First is we multiply the numerator first. After that, multiply the denominators. Then reduce the resultant fraction to its lowest terms. For example, 2 over 3 times 4 over 5. We start multiply the numerators, which is 2 times 4 equals to 8. Then the denominators parts, 3 times 5 equal to 15. Okay, now the product is already in the lowest term, so we no need to do the simplify. And the final answer will be 8 over 15. Next.
Okay, next I will show you how to multiply whole numbers and fraction. Okay, this is the equation. Okay, there are a few steps we can
do. Okay, first we use models such as folding papers. Okay, take 4 sheets of square papers. Okay, then divide it into half. Because we want show 4 groups, that's why we use 4 sheets of papers. Okay, after we divide it into half, we take out half part and shade it or color it with different colors. And then we need to count how much half are there. So in this models, we have 4 half, and then we take out the half part and rearrange it and become like this. So the answer will be 2 because we have 2 square, or we can use half plus half plus half plus half equal 4 halves. 4 halves is equivalent into 2. Okay, next we also can use a number line. Okay, first we draw a number line like this. Okay, and each part represent half. Okay, the question 4 times half. So we need to multiply half 4 times. Okay, what we need to do, we do like this. 1, 2, 3, 4. So one part represent half, half plus half plus half plus half equal 4 and half, equivalent to 2. Okay, next.
Okay, so now I will show how to multiply proper fraction by using area model. And the question is, what is the product of 3/4 and 1/3? Okay, so first we cut out a big square into 4 parts. And since the fraction is 3/4, so we shaded 3 parts in the column. And next we cut out square into thirds, going side to side in horizontal. Okay, so now we look at the horizontal line, we separate into 3 parts. And okay, so I'm using different colors to show difference between 3/4 and 1/3. Okay, now we look at how many sections overlap between 1/3 and 3/4. Okay, so these 3 sections that I highlighted will be the answer for numerator, which is 3, whereas the denominator is the total sections in that big square, which is 12. Okay, so the answer we get is 3/12, and we simplify it into 1/4. Next.
Okay, we can also do the multiplication of proper fraction using the fraction pi. For example, 3/4 times 1/2. First, we draw a circle with 4 parts and shaded or color the 3 of the parts to represent 3/4. After that, because it times 1/2, then we draw a line, a red line shown at the diagram to divide the shaded parts of quarters to represent 1/2. Then divide each part of the quarters into half to make it become equivalent. Now we have 8 parts in total. So we will get the answer 3/8 because the shaded parts, which represent 6/8, have to divide into 2. Done. Next.
Alright, the next one is multiplication of fraction with the improper fraction. Okay, first of all, we need to draw the bar. As we can see that in this one, we color 7 out of 5. So 1, 2, 3, 4, 5, 6, 7, and then this was, and then all of this is 7/5. And if you can see, this also is same as 1, 2/5. Okay, after that, we also need to because it's multiplied by 4/3, right? So we need to divided this bar into 3 sections, 1, 2, 3. So but we need 4/3, right? So we need to clone this table another beside that. So we also need to divide it into 3 parts, and after that we
we shade the row 1, 2, 3, 4 and equal to 4 over 3, and also same as 1 over 3. So based on this, we need to total up of all the combination of color and shaded side, and if you can see this 15 is always 6 and this is 5 and this is 2, so 15 plus 6 plus 5 plus 2 equal to 28. And then so the final answer is 28 over 15 because we can see this is the only one that have all the shaded and colored one. That's all. Next.
Okay, let's move to multiplication of mixed fraction. Step 1. We have 2, 1 over 3 multiplied by 2, 2 over 4. Then step 2, convert to improper fraction. So we have 7 over 3 multiplied by 10 over 4. And step 3, we will multiply that number for we combine the first the above one 7 multiplied by 10. Then the down 3 multiplied by 4. So we get 17 multiplied by so we get 17 over 12. Then convert back to mixed fraction. So we get 5 10 over 12. So for this fraction, we can still simplify it. So 5 10 over 12 to make it simplify, we get 5 over 6. So move to another example. Think this circle of pizza. So we have 1 3 over 8. So we have question 1 3 over 8 multiplied by 3. 3 is also 3 over 1. So we have pizza. We have 1 3 over 8 pizza. Then convert it to improper fraction. 1 3 over 8 is 1 pizza and 3/8 of another pizza. And after move, okay, next slide. Back. Sorry. Okay. First convert the mixed fraction 1 3 over 8 to improper fraction. Then we get 11 over 8. Back. Okay. Cut the okay. So we cut the whole pizza into 8. So we can see that the whole pizza cut into 8, and to for the another pizza, how many left to make it 11. So we can see that the another pizza we need to cut it to 3 because 11 minus 8 is 3, right? So for another pizza we make it to 3 parts. So and for next step is for next step is we multiply that by 3. So 1 3 over 8 multiplied by 3, we get 11 over 8 multiplied by 3 over 1, so we get 33 over 8. That's mean we have 33 part, 33 cut of pizza. So okay, and next slide. Okay. Okay. Then if we can see that for the whole pizza is cut to it, right? So we have so to make okay. For multiply by 8 we get 32, right? So before this we have 33 cut of pizza. So that 32 cut we make it to 4 whole pizza because for one pizza it have 8 cut. So we put that 32 cut into 4 whole pizza. So for the balance one we make it into the other pizza. So for the other pizza we have 1 cut. So and this look like the one line. 1 over 8 multiplied by 3 is 11 per 8 multiplied by 3 over 1, and we get it 33 per 8 and convert it to mixed number. Mixed fraction is for 1 over 8.